Hi there. Welcome to the first lesson of A2 Unit 3 paper. We are going to start with the first topic, that is topic 12. The first lesson under first topic is data governance and data integrity. So we are going to learn data governance and data integrity as our first lesson in A2, and then will have some practice questions and a past paper questions, and the answers are given in you can download the answers in the link given in the description box. Right, so let's start with first learning what data governance is. We are going to learn data governance in relation to a database. Data governance in relation to a database refers to a set of processes, policies, and guidelines that govern the management, quality, availability, integrity, and security of data within a database environment. It covers the overall strategy and framework for how an organization collects, stores, and organizes the collected data to ensure that accuracy, consistency, and compliance with relevant regulations and business requirements are there. So, data governance is essential for maintaining data quality and the reliability of that data. Let's look at the key components of data governance in a relation to a database. This include 9 components. The first component is data policies and standards. This is about defining and documenting policies, rules, and standards for data collection, storage, how the data is used, and how we access the data within the database. Second, we have data quality management. In this, we implement processes and mechanisms to ensure the accuracy, the completeness, and the consistency and timeliness of data stored in the database. The third component is data integrity. As the second subtopic, we are going to learn data integrity in the lesson today in detail later. Data integrity refers to the data's accuracy, consistency, and reliability throughout the life cycle of that data. Ensuring data integrity is essential to maintain the trustworthiness and the usability of data within the database environment. Next, we have metadata management. What is metadata? Metadata is data about data. This means maintaining a comprehensive inventory of data assets to provide the context and enable effective data management. In the next lessons also we are going to talk about metadata and the data dictionary in a separate lesson, so you will learn how metadata is used and created. uh, Next is data access availability and the security. Establishing access control, authentication mechanisms, and data protection measures to safeguard the confidentiality, integrity, and availability of data stored in the database comes under this component. The sixth component is about data handling procedures and data lifecycle management, defining procedures for data retention, archiving, and deletion while complying with legal and regulatory requirements. Seventh is data stewardship, that is assigning responsibilities and accountabilities to individuals, or it could be the teams who oversee the implementation and enforcement of data governance practices. It includes monitoring and resolving data related issues as well. Next, compliance and regulatory adherence, alignment of data governance practices with relevant industry regulations, data protection laws, and policies covered under these industry regulations. Uh, Industry regulations are requirement the business needs to meet because it operates in a specific industry, such as, for an example, banking, shipping, insurance, healthcare. GDPR is an example of data protection laws that is famous internationally. The ninth component is archiving data. Archiving means moving the old data that are not needed for day-to-day operations of the organizations to a offline storage. We normally compress the data and archive. Archives should be kept offline in a uh, magnetic media storage or in the cloud. Uh, it doesn't have to be on a speedy storage device because we are not using that data in our day-to-day operations. Implementing data governance practices is not straightforward. Social and ethical issues can significantly impact data governance practices. We will now discuss some examples of how these issues can influence data governance. Right. First up, privacy and data protection concerns. With the increasing amount of uh, personal data being collected and stored in databases, concerns about privacy and data protection have become very important. Data governance must address these issues by establishing strict policies and controls for data access, usage, and sharing to ensure that compliance with privacy regulations and that protect individuals' sensitive information. Secondly, data biases and fairness influence. Data governance should address the issues of bias in data collection and usage. Biased data can lead to unfair outcomes and discrimination, and biased data can lead to take incorrect decisions. Uh, to identify and mitigate biases in data, ensure diverse and representative data sets, and promote fairness in decision making. The third example is consent and transparency. Data governance should uphold principles of informed consent and transparency. Individuals should have a clear understanding of how their data is collected, it is used, and how the data is shared. Uh, the data governance practices should include mechanisms for obtaining consent, providing clear privacy notices that are understandable and readable, and enabling individuals to access and manage their data. Another impact area is data ownership and control. Ethical considerations could arise regarding the ownership and control of data. Data governance should define policies and guidelines regarding data ownership rights, data custodianship, and data stewardship to ensure responsible and accountable handling of data. Data security and threats is the next impact example. Data governance must address the ethical implications of data security. It involves implementing robust security measures such as encryption and then access controls, and then we need to regularly assess the security measures that we have taken, whether that is enough, and we need to protect data from unauthorized access, breaches, and cyber threats as well. Next is algorithmic transparency and accountability. Uh, with the increasing use of algorithms and machine learning in decision making, data governance needs to address the transparency and accountability of these algorithms. Organizations should ensure that their algorithms are understandable, explainable, auditable, and they are accountable. So, uh, so these are the things that we need to consider. Finally, we have social impact and community well-being concerns. Data governance should consider the broader social impact of data collection and usage. Organizations should assess the potential impact on communities, ensure that data practices respect the cultural norms and values, and consider the well-being and interest of individuals and communities affected by these data activities. By implementing effective data governance practices within a database environment, organizations can improve data reliability, enhance decision making processes, minimize risk, and maintain compliance with legal regulatory requirements. It is important to note that the data governance is a concept rather than a set of rules. There's no single authoritative definition for the term, as different groups and organizations will have their own opinions about data governance. Okay, next we are going to learn data integrity in data. We learned that data integrity is one of the components in data governance. Data integrity refers to the accuracy, consistency, and reliability of data throughout its life cycle. It ensures that data remains intact and unchanged from its original form, regardless of any external factors or manipulations. Data integrity is crucial for maintaining the quality and trustworthiness of data in various systems and applications. Uh, through data integrity, what we are going to achieve? Data integrity is a crucial concept in the world of data management, ensuring that data remains accurate, consistent, and reliable throughout its life cycle, right? So it aims to achieve several key objectives, all of which are essential for maintaining the trustworthiness of data. So, what does data integrity tries to achieve? Let's see. So, we discuss on six aspects here. Number one is accuracy. Data should be accurate and free from errors or discrepancies. It should reflect the correct values and information that is intended to represent. For an example, in a medical database, the patient's blood type should be accurately recorded as A plus, B minus, O positive, whatever, etc., to avoid potential life-threatening blood transfusion errors. So number two is consistency. It guarantees that data is uniform and follows predefined standards and formats. It should not conflict or contradict with other related data elements. For an example, in a sales database, all the product prices should be consistent in terms of currency format. Let's say US dollar, euro, or sterling pound, to prevent the calculation errors. Number three is completeness. Data should be complete, meaning that it contains all the required information without any missing or incomplete fields. Missing or incomplete data can lead to erroneous results, system failures, and affect the overall integrity of the data set. For an example, in an employee database, each employee's record should include all mandatory information like the employee ID, the employee name, contact details, job title, likewise. Number four is validity. Confirm that data adheres to defined rules and constraints and that data is valid. Preventing inclusion of incorrect or unauthorized data. For an example, let's say an online shopping website is there. You should validate customer payment information to ensure that only valid credit card numbers are accepted. There are available services that ensures the card number that is entered is a valid Visa card or Mastercard or whatever the credit card number. Number five is reliability. Ensure that data is trustworthy and can be depended upon for decision making. For an example, if there's there are financial institutions and they must maintain reliable transaction records to accurately calculate the account balances and detect any fraudulent activities. Last one, number six is security. Data integrity is closely linked to data security. So some of the exam questions I have seen, they have asked what is the difference between data security and data integrity. So that is very close, but it is different. So adequate measures should be in place to protect data from unauthorized access, modifications, or tampering. Security measures like encryption, access controls, and backups help maintain the data integrity. For an example, healthcare records of the individuals must be securely stored and only accessible to the authorized medical personnel to prevent that data breaches and the privacy violations. So we have to implement various techniques and practices to maintain data integrity. Let's look at what those techniques and practices are. Up first is data validation. Validating data upon entry or import to ensure it meets the defined criteria and standard is important. You may have heard the concept the garbage in, garbage out. So if you are feeding or if you are inputting garbage data, what we are getting from the system also garbage output. So we don't want to store invalid data and try to stop it at the source through data validation. That is, at the input level, we need to validate and make sure that data is not uh, added to the data stores. Data backups is another. Since we are dealing with electronic system to store data, failures are possible, right? So therefore, regularly backing up data to prevent loss or corruption and enabling recovery in the case of a data integrity issue is really important. For an example, data in one of the tables may be corrupted due to a magnetic interference. So we must be able to import the relevant data from a backup and bring back the integrity of the data. Next, access control. It's an extremely important practice in this time manage. Implementing security measures to control and restrict access to data, ensuring that only authorized individuals can modify or manipulate. It is important to safeguard data integrity. Data encryption is the next technique. Using encryption techniques to protect data during transmission and storage, making it unreadable to unauthorized parties. So, access is important. For example, encrypting the personal information of users stored in the database so that even the database administrator cannot read it is that is important, right? So we are still storing the password, so even the database administrator should not be able to uh, look check the password. That's why we are doing encryption. Conducting regular audits and checks to verify the accuracy, consistency, and compliance of data with established standards is another practice to ensure that we have data integrity. You may have the policies in place and systems in place, but you need to audit and see whether what you have set is the policies and the uh, systems are actually working correctly. Lastly, error detection and correction. Employ mechanisms to identify and correct errors, so inconsistencies in the data, such as checksum or redundant data, or we need to validate them and make sure those are not there to ensure that we have the data integrity. So, if we look at the methods of ensuring data integrity, we can divide it into logical integrity and physical integrity at a very broader level. There's a third method called the business rules integrity, which we will just touch at the end, but that is not directly connected to the data integrity in the database. The logical integrity of a database refers to the correctness and consistency of data relationships and dependencies in a database. It ensures that data stored in a database adhere to rules, constraints, and relationships, maintaining the uniqueness and integrity of individual records. The physical integrity of a database refers to the protection and preservation of the actual data stored in the physical storage mediums. Uh, it ensures that the data remains intact, free from corruption, and accessible as intended. Maintaining the physical integrity of a database is essential to ensure the reliability and the privacy and also the availability of the data. Now let's go deep into logical integrity of a database and see how we can achieve it. There are three aspects to achieving logical database integrity. They are entity integrity, referential integrity, and domain integrity. Uh, Entity integrity ensures that each entity has a unique identifier, or we call as primary key. It guarantees that there are no duplicate or null values for the primary key, maintaining the uniqueness and the integrity of individual records. Second one, the referential integrity ensures that relationships between tables or entities are maintained accurately. It involves enforcing rules or foreign keys, ensuring that any value in a foreign key field matches a primary key value in the reference table. Referential integrity prevents orphaned or inconsistent data by ensuring that related data remains synchronized. Finally, the domain integrity defines and enforces the valid range of values and constraints for each attribute or, uh, or file within a table. It ensures that data entered into a field confirms uh, to predefined rules such as data type, length of that data, format of that data, or allowable or unallowable values. So, domain integrity prevents invalid or uh, non, non invalid data or meaningless data from being stored in the database. Okay, though these methods that we learned are available, yet we can design a database with many errors that break the data integrity. Let's look at what database design errors can happen that compromise the logical integrity of the database. Number one is missing or inadequate primary keys. Every table in a database should have a primary key that uniquely identifies each record. Additionally, using inappropriate fields such as primary keys such as non-unique or changing values can result in data inconsistency. Number two is inconsistent or incorrect data relationships. The relationships between tables should accurately represent the associations between entities in the real world. Design errors can include missing relationships, incorrect cardinality, that means one to one or one to many, etc., or the improperly defined foreign keys. Such issues can lead to referential integrity problems and incorrect data retrieval. Number three is the lack of constraints and validation rules. Without proper constraints and validation rules, data integrity can be compromised. Constraints such as unique constraints, not null constraints, and check constraints help enforce data integrity rules. Without this, invalid or inconsistent data can be stored, affecting the overall quality of the database. Number four is redundant or denormalized data. Redundancy occurs when the same data is stored in multiple places, leading to data inconsistency if updates are not correctly propagated for all the places. So, one place might have a new data, the place might have the old data for the same criteria. So denormalization, which involves combining data from multiple tables into a single table for performance reasons, can also introduce logical integrity problems. Inaccurate updates or deletions can result in inconsistencies between the normalized data and the original source data. Number five is inadequate error handling and exception management. Incomplete or improper error handling mechanisms can result in data integrity problems. When errors occur during data manipulation operations such as insert, updates, or when we are deleting, the database should handle them appropriately and roll back changes if necessary. Failure to do so can leave the database in an inconsistent state with corrupted data. Number six is poor naming conventions and documentation. Uh, Clear and consistent naming conventions help maintain logical integrity by ensuring that tables, columns, and relationships are accurately represented and easily understandable. Lack of proper documentation can make it difficult for the programmers and the database administrator to understand and maintain the database structure, leading to potential errors. So there you have six database design errors in total that can compromise the logical integrity. To mitigate these database design errors and enhance logical integrity, it is important to follow good database design principles such as normalization, defining the appropriate constraints, establishing correct relationships, and implementing robust error handling mechanisms. We learned six database design errors, and next let's look at software bugs or errors that can compromise the logical integrity of a database. Here are five examples. First example is incorrect query construction. Uh, the bugs in the code that generate SQL queries, the structured query language queries, can result in incorrect or incomplete queries. This can lead to incorrect data retrieval, data updates, or data deletion that causes the logical integrity of the database. Second error is the failure to enforce constraints. Bugs in the code responsible for enforcing constraints, such as unique constraints or foreign key constraints, can result in violation of logical integrity. For an example, if a bug prevents the enforcement of unique constraints, duplicate records may be inserted to the database, violating the uniqueness requirement. Third software error is race conditions. Race condition occurs when multiple processors or threads access and modify the database simultaneously. If proper synchronization mechanisms are not in place, these race conditions can lead to data corruption and logical integrity problems. Fourth software error is incorrect data validations. In data validation code can result in inadequate validation checks or incorrect validation logic. This can allow invalid or inconsistent data to be stored in the database. Fifth and final software error that could happen is inadequate error handling. Bugs in error handling code can result in improper handling of exceptions or failures during database operations. If errors are not appropriately coded, logged, and handled, it can leave the database in an improper state. Now that we just learned the software errors that could cause logical data create integrity issues, let's look at how we can avoid or correct these software errors. It's crucial to follow uh, good software development practices that include uh, these activities. First and foremost is thorough testing. Humans make errors, right? And it is no exception for software programmers as well. So, conducting comprehensive testing to identify and fix bugs related to logical integrity is a must. This include unit testing, integration testing, and regression testing so that we can identify bugs or errors. Secondly, conduct periodic software code reviews. So, when we are reviewing the program code that's written by each of us, when we are doing the peer reviews, it allows us to catch logical integrity issues early on. Peer review and feedback can help and identify potential bugs, and then we can fix those bugs and improve the quality of the code as well as educate the developer on bad programming practices and database design practices to avoid for future similar development. Third is making sure people proper error handling is implemented in the code. Implementing robust error handling mechanisms ensures that errors and exceptions are handled appropriately so that it prevents the database from being left in an inconsistent state. Fourth is login and monitoring. Login means saving all the changes uh, in a log. So it has a history of all changes happen, who did the change at what time, what change happened. So we can see the history of changes and then we can use those logs uh, to monitor and also track any issues happen and identify logical integrity issues. We also can use those logs to troubleshoot and diagnose bugs if we come across later on. Finally, continuous improvements regularly assess and improve the software development process to prevent future bugs and enhance logical integrity. Human errors can also have a significant impact on the logical integrity of the database. Here are some common examples of human errors that can compromise the database logical integrity. Uh, Incorrect data entry, right? If the users are not trained exactly what data to enter, then incorrect data will be saved to the database. If, for example, initials of person's name is entered in a full name field, incorrect name will be saved in the database. Inadequate data validations also lead to incorrect data saves and compromises logical integrity. For an example, if there are no validation to prevent someone from entering a value greater than, say, 150 for their age, then users can enter any value that are not realistic for age. Improper data updates or deletions. Human operators can inadvertently update or delete the wrong record or apply incorrect modifications to the database. So, this can result in data inconsistencies, loss of critical information, or incorrect data relationships that affect the logical integrity. Next is mishandling of database transactions. Improper handling of transactions by human operators can lead to logical integrity problems. For instance, forgetting to commit or roll back a transaction appropriately can leave the database is in an inconsistent state that compromise the logical integrity. Next is misinterpretation of database relationships. Human database operators may misunderstand or misinterpret the relationships between the tables or entities within the database. So this can result in incorrect data retrieval, incorrect data updates, or incorrect queries that is leading to logical issues. Another is inadequate backup and recovery procedures. Human operators responsible for database backup and recovery may overlook important steps or fail to follow proper procedures. So, insufficient or improper backups can result in the loss of critical data, so making it difficult to restore the databases to a consistent state if there are any issues. Next is the lack of training and education. This is a universal requirement. Humans must be trained and educated on what they are doing and the proper way of carrying out the data entry or any other task discussed so far. So, in order to accurately do these things and to prevent errors as much as possible, training and education is really important. Now let's look at the mitigations available to reduce or eliminate the human errors. First and foremost is proper training and education that we just discussed. Human properly trained and educated is able to carry out their duties correctly without errors. So periodic retraining and upgrading is also important to make sure that they are up to date with the latest database and system changes and improvements and new technologies. Secondly, there we need to implement data entry controls. These could be manual check controls or could be coded controls into software such as validations, mandatory inputs, auto formatting of the data we enter, uh, because like if you take the date it could we can enter in different ways, but there should be auto formatting that is written in the software. So these controls make sure that errors at data entry are avoided. One extreme data entry control is to let two users enter the same data parallelly and compare to see any mismatches. Third is setting up proper user policies. It deals with password structure and strength of the password, sharing passwords, access rights, uh, log on and log off requirements, uh, acceptable use of company IT system, penalties on in improper uh, or unauthorized use of the system, etc. The fourth mitigation action is use of transaction management correctly. Implement proper transaction management practices to ensure atomicity, consistency, isolation, and durability properties of database operations. These four are known as ACID properties. The word ACID comes from the first letter of those four properties mentioned, which are atomicity, consistency, isolation, and durability. So this helps safeguard logical integrity and provides mechanism for error recovery. The fifth action is regular audits and reviews. Conduct regular audits and reviews of the database to identify inconsistencies or errors. This include verifying data relationships and constraints and the accuracy of data entered into the database. Sixth possible action is backup and recovery procedures. We need to establish robust backup and recovery procedures to protect against data loss and ensure the ability to restore the database to a consistent state if any errors occur. Seventh is documentation and standardization. Uh, we need to maintain clear documentation of the database structure, database relationships, and data handling procedures. And we also need to standardize naming conventions, coding practices, and data entry guidelines so that all the team members follow the same standards, naming conventions, and coding practices, ensuring that data integrity is secured. So far, we discussed conceptually what compromise database logical integrity and how to prevent it. Now, let's look at database mechanisms and techniques available to enforce the logical integrity. Do remember the databases in concern are relational databases. So all databases provides the ability to define primary keys and foreign keys. So primary keys uniquely identify each record in a table, while foreign keys establish relationships between tables by referencing the primary key in the parent tables. In other words, foreign keys prevent users from entering a value that is not already available as the primary key in the parent table. Constraints is the next technique. Constraints are rules and conditions applied to database tables to maintain the data integrity. Common types of constraints include unique constraints that enforces the uniqueness, and not null constraints that prevents the entering null values into the database, and check constraints that defines the specific conditions for field values. So these constraints validate the data before saving them and rejects if the constraints is not evaluated to true. Triggers is the third. Triggers are stored procedures that are automatically executed when a specified event occurs, such as when we are inserting data or updating or deleting records. Triggers can be used to enforce additional business rules or perform data validations before changes are committed to the database. Unfortunately, Microsoft Access database tool that we are using for A2 does not support triggers. Fourth is database normalization. Uh, Database normalization is a process that minimizes data redundancy and dependency by organizing tables and relationships according to specific normal forms. Normalization helps ensure data consistency and reduces the risk of logical inconsistencies. Uh, by maintaining logical integrity, databases provide reliable and consistent data, enabling accurate analysis, reporting, and efficient data manipulation. Database management system, the DBMS, typically provide features and tools to enforce and manage logical integrity constraints, ensuring the data integrity. Uh, with that concludes our discussion on logical integrity. This is a previous slide that you can remember, and where we discussed the two types of integrity. So, we have now finished learning on logical integrity, and we'll next move to the next one, which is physical integrity. Physical integrity of a database refers to the protection and preservation of the actual data stored in the physical storage medium. It ensures that the data remains intact, free from corruption, and accessible whenever we want. So, maintaining the physical integrity of a database is essential to ensure the reliability and availability of the data. Here are some key aspects related to the physical integrity of a database. So, number one is storage media errors. Storage media such as hard disk drives or solid state drives can develop errors over the time or due to manufacturing defects. So, these errors can corrupt data, making it inaccessible or introducing the inconsistencies. Number two is hardware failures. Hardware failures such as hard disk crashes, power supply issues, or memory errors can lead to data corruption or data loss. So these failures can result in incomplete or incorrect data being written to our uh, storage media, so that ultimately compromise the integrity of the database. Number three is environmental factors. Physical factors in the environment such as temperature fluctuations, humidity, electromagnetic interferences, or even the dust can damage storage devices or affect their performance. Fourth aspect is accidental damage or mishandling. Fifth, physical security breaches such as unauthorized access to the physical server room or tampering with the storage devices can compromise the integrity of the database. Sixth is G-force. G-force typically refer to the impact or stress experienced by the physical storage devices such as hard disk drivers or solid state drivers due to acceleration or deceleration forces. The G force can be a concern for databases because excessive or abrupt changes in motion or vibration can impact the physical integrity of storage devices, that's leading to data corruption, loss of data. So when the storage devices are subject to a high G force, it can cause the read-write heads to crash, uh, that result in physical damage and data loss. The seventh and the final aspect is network issues. Database systems rely on networks for communication between servers, client and storage devices. So network problems such as packet loss, latency, or interrupted connections can disrupt data transfer, and that compromise the integrity of the data in the database. Although many of these challenges seem extreme, still data integrity needs to be maintained in data measurement and storage devices such as spacecrafts, volcano monitors, aircraft black boxes, and many other places where physical protection is really a major problem. Now let's see measures we can take to mitigate the physical factors compromising database integrity. Number one is implement reliable hardware, use high quality, reliable hardware components for database servers and storage devices. Hardware used for a personal computer, for example, is not suitable for a database server. If we consider the hard disk, a database server's hard disk will be executing 1,000 times or even more read writes than your laptop or home computer hard disk. Uh, so, regularly monitoring the health of hardware components and addressing any potential issues promptly is also important. The next measure is to implement redundancy and fault tolerance systems. Use redundancy storage systems such as RAID, redundant array of independent disk, to ensure data redundancy and fault tolerance. Use redundant network cards so that you always have a duplicate, so that if one fails, the other will still provide the connectivity. Redundancy of all potential failure points reduces the risk of failure and gives you time to fix the failed hardware components. But when we are using redundant resources for all these, redundant storage, redundant network, and all that, it comes with the cost, right? So you need to decide what sort of redundancy you are going to implement. Uh, Employing backup and recovery strategies is another measure. Establish robust backup and recovery mechanisms, including regular backups and offsite storage, to protect against data loss and enable restoration to a consistent state in case of a physical failure. Fourth one, ensure physical security. Implementing physical security measures such as restricted access to the server rooms, CCTV camera systems, and access controls to prevent unauthorized access or tampering with the uh, database infrastructure. The fifth measure is to monitor and maintain environmental conditions, maintain proper environmental conditions, including the temperature, the humidity control, to minimize the risk of physical damage to storage devices. You must have seen that server rooms are typically air conditions for 24/7 and is in a closed place. This is to control the humidity and the temperature. Servers generate a lot of heat, right? So it's not if it is not cooled down, the parts will overheat and it could damage and it could uh, cause the data loss. Therefore, we have air conditioned systems specifically designed and used in the server rooms. The final measure is to conduct regular maintenance and inspections. Regularly, we need to inspect and maintain hardware components, including the storage devices, the network's infrastructure, and the environment. So, by addressing these physical factors and implementing appropriate measures, the organizations can minimize the risk of physical issues, and we can then ensure the integrity of the databases, the reliability, and the availability of data. The third integrity type that I mentioned at the start is at the lesson is business rules integrity. This we don't learn in detail. A connected factor for database integrity compromisation is business rules integrity, though this cannot be controlled within the scope of the database or the database systems. This has an impact on the database integrity as well. So, business rules integrity refers to the application specific rules and constraints that govern the integrity of data in the database. So, these rules are specific to the organization's requirements and their business and all that. So, for an example, a maximum order quantity for a product, or the pricing calculations, or data validations could different from one organizations to the other. So this conclude the lesson 1 of topic 12 in A2 unit 2 paper. Let's see some practice questions on this area. Uh, I have given 4 practice questions, and the answers for these practice questions you can download from the link that is given in the description box. And this is a past paper question that I got from 2022 January paper, and you can download the marking schemes also from the Edexcel IT Guru website. So thank you for listening to the first lesson. So we will cover next meet from the lesson 2 of topic 12. So until then, good luck with your studies and thank you.